Welcome to this lesson. We are looking at chemistry. This is a chemistry presentation, and we are looking at criteria of purity. So this is one of the topic which is there in chemistry that you need to understand. Criteria of purity. I'm your tutor, Mr. Zimba. One thing that we need to understand is that there is what we call a pure, and also there is what we call a mixed substance. Let's look at these two. A pure substance is one that contains no impurities. A pure substance contains only one type of material and has a definite chemical and also physical properties. Furthermore, a pure substance has a fixed sharp melting point and a fixed sharp boiling point under specific given condition. An example of a pure substance we can depict here is distilled water. Distilled water is a pure substance because it does not contain any impurities. And because it's a pure substance, it's supposed to have a fixed melting point and a fixed boiling point. For instance, distilled water boils at 100 degrees and also will turn into an ice at 0 degrees. So that is one of the things we need to understand. So distilled water will boil at 100 degrees. So 100 degrees, that is the boiling point of distilled water. Then it will turn into ice at 0 degrees. So this is how it's going to be because it's a pure substance. So if a substance contains any amount of impurities, we call it a mixture. What is this mixture? So a mixture usually melts or boils over a range of temperatures. Water with some salt, this is a mixture. Water, you also add some salt, you stir, it is called a mixture, a solution. Why is it called a mixture? Because it contains both water and salt particle that have been physically combined. That's why it is called a mixture. Look at these two structures here. We have this diagram of a pure element and we have a mixture. As we said during the preamble, a pure substance does not contain any impurities. It's pure. If it's white, it is just white. There's no black and white. But look at the other side. This is a mixture. Why is it a mixture? Because it contains different structures here. We have the white ones and we have these other silver ones. So this is called a mixture. Wow, this other side is called a pure element. So sometimes they may give these diagrams and then they'll say which one is a pure and which one is a mixture. So this is how you can distinguish the two. A pure only has one element. This mixture contains different components. All right, having looked at the mixtures, let us look deeper into these same mixtures. So under chemistry, we only have two types of mixtures. We have what we call a homogeneous mixture, and there's what we call heterogeneous mixture. Let's look at these two types of mixtures at an individual level. Homogeneous mixtures, what are these? Homogeneous mixtures, you cannot see the different components. So these, when they mix, they become one, meaning these are substances, they are uniform. It has the same color or texture throughout, and the components are evenly distributed. An example is any solution that consists of a solute that has dissolved completely in a solvent, such as water and also sugar. Of course, you may be wondering, what is this solute? What is this solvent? A solute is a substance that can dissolve in a solvent. That is the simple definition that I can give. A solute is a substance that can dissolve in a what? In a solvent. Okay, an example of a solvent, we can say water. So an example of a solvent, we can say water. An example of a solute we can depict here is salt. So this is an example of a homogeneous mixture, because when you mix salt, you mix it with water, you stir, they become one. So these are called the homogeneous mixtures. This is what I was explaining about. We have sugar, water, we mix them, they form a solution, and this solution is a homogeneous solution, or rather homogeneous mixture. Let us dive in and look at the heterogeneous mixture. Heterogeneous mixture, this is a non-uniform. Remember, homogeneous, we said they are uniform. These are non-uniform mixture. What does this mean? In heterogeneous mixture, you can usually see the different components. So meaning these, when they mix, they do not become one. The components are not evenly distributed. An example we can depict here is sand and water. When you mix sand and water, you even stir, you still see the sand, you still see the water. These, they don't mix and become one. These are called the heterogeneous mixtures. So these substances are non-uniform. They are non-uniform. The other substance, which is homogeneous, those are uniform. These are non-uniform. The other ones, they are uniform. These are non-uniform. Meaning, these, when they mix, they do not become one. The other side, which is homogeneous, when you mix them, they become one. Those are the differences. These are some of the examples of heterogeneous mixture. We have pizza. We can see there are different components, because with heterogeneous mixtures, you are able to identify different components. Same applies to the sandwich there. You can see this is a vegetable, this is a bread, this is cheese. You are able to identify different components. Even look at the salads. You can see this is a tomato, this is that, and this is that. These, they do not mix and become one. They are heterogeneous mixtures. In chemistry, there are two types of changes. There is what we call a physical change, which is mostly reversible. We also have what we call as a chemical change, which is irreversible. Let's look at these two. So a substance undergoes various changes when they are subjected to different temperatures. Sometimes they can undergo a physical change. Sometimes they can undergo a chemical change, which is a permanent change. What is a physical change? A physical change is a change in which no new substance is formed. So with physical change, you can identify it in the following ways. Just from the definition, we have said no new substance is formed, meaning if it is water, the water in a liquid form, you put it in the freezer, it turns into a solid. Of course, changing of states from liquid to solid That is called freezing. And that is an example of a physical change. Why? Because that process can be reversed. You get water, put in a cup, you get the cup, you put in the freezer, you let it be there for maybe 3 hours, you remove it, it is a solid. When it is exposed outside, it starts to melt. It will go back to the liquid. That's why we are saying physical change, it is reversible. The mass of the substance remains the same. That is with physical change. The process, like I've said, it can be reversed. The energy changes occurs during these changes of state. There is some energy change, and we said it can either be an endothermic or an exothermic change. This is an example. We have liquid water turning into ice. So this is a physical change. It can be reversed. What is a chemical change? A chemical change is a type of change in which one or more new chemical substances are formed. So the new substance which is going to be formed will have physical properties and chemical properties that are very different from the original. What do we mean here? Look at this scenario. Let's say you have this paper. This paper, you burn it. It turns into what? It turns into ashes. It turns into ashes. So this is a chemical change. Why is it a chemical change? This is a permanent change. This reaction, it cannot be reversed. You can't say, no, let me turn ashes, I turn them back into a paper. You can't. This is a chemical change. So a chemical change is permanent. You can identify a chemical change in the following ways. Of course, a new substance will be formed, like what we're just from explaining. You have paper. You know the volume of that paper. You burn that paper, it turns into ashes. Ashes are new. They were not there. So that's why we are saying a new chemical substance is going to be formed. The mass of the original substance will also change. It will change the mass. It won't be the same. And the process is irreversible. It cannot be reversed. You can't burn the paper and then you say, let me get these ashes, I turn them back into the paper. So you can't, because it's a permanent change, this one. Energy is given out or taken in as a new chemical substance forms. We have an example there. If you get raw eggs, you buy eggs, kayangani 3 kwacha, you buy an egg, ya 3 kwacha. That egg, inside there is liquid. When you get the same egg, you boil it. The inside part becomes a solid. That change is a chemical change and it is permanent. You can't say, no, me, I want to have a raw egg again. You can't. You can't reverse boiled egg, you turn it back into a liquid. You cannot. Why? Because this is a chemical change, and the chemical changes we are saying they cannot be reversed. As we sum up our lesson for today, let us compare the two. So these are examples of physical changes, and also we have chemical changes. We have water turning into an ice, which can be reversed. Ice can also turn into water. Here we have the egg yolk. So we have an egg. An egg, when you fry it, you cook it, it becomes like this. You can't reverse it. You can't say, no, this egg should go back to its normal stage. You can't. So when you cook the egg, you can't reverse it. That is irreversible. It is a chemical change. So physical change can be reversed, while chemical change cannot be reversed. Those are some of the points that we need to consider between physical changes as well as the chemical change. Thank you for watching this presentation.